Okay, so here's the video for the Peardeck for today, 12/9. I'm just going to continue with this slide. So the work example showed has to solve an inequality in the form of y equals ax plus b. How does your method changes if the inequality is in a different form? Okay, so since inequalities and equations are solved the same way, so since they're solved the same way, okay, the method of how to solve it, even if it's in a different form, does not change. Even if it is. So if it's written in standard form, you write it, you solve it the same way. Okay, so Allen Campbell Truth hikes down from the camping site at an elevation of 4,800 feet to the base of the mountain, which is at sea level. They hike down at a rate of 20 feet per minute. Okay. So write a function h of n to show the truth elevation as a function of time in minutes. Label the function of the on the coordinate plane. Okay, so we started at 4,800 feet and we're going down. So our slope is going to be down 20 feet per minute. So let's use h of n. So h is equal to, so we're hiking down. So you can write it two different ways. I just like to put the slope first. So negative 20m and then plus 4,800 feet. Okay. Identify the independent and independent quantities and their units. So independent would be, let's see, the independent variable most of the time is time. So it can be minutes. And then our dependent would be the number of feet. Okay, so let's go independent quantity. Is the number of minutes. Okay. Number of minutes hiked. And the dependent quantity is the elevation in feet. So analyze the function, identify that each characteristic, and explain what it means in terms of this form and situation. That didn't come out. Okay, so what is our slope? Well, it's negative 20 because we're going down, so it's negative 20 feet per minute. So our slope is going to be negative 20. And what does that represent? Well, this represents a decrease of 20 feet per or every minute. Okay, how about the y-intercept? Well, the y-intercept is way up here, and that is the 4,800 feet. So the y-intercept is the 4,800 feet. And what does that represent? That's where the troop started. So the troop elevation of 4,800 feet. Okay, how about the x-intercept? Well, the x-intercept is going to be down here. So it looks like that's when they get to the camp base, which is at sea level. Sea level will be 0 feet above ground, and it's a 240 minutes. So it takes them 240 minutes to get all the way to the bottom. So what is our x-intercept? So it's 240. So the hikers reach the bottom of the mountain in 240 minutes, which is 4 hours. 240 divided by 6. Okay, what's our domain? Okay, so if you remember, our domain is our x value. So our domain would be from 0 to 240. So our domain is 0. Let me look for those symbol. Let me use, we're going to use less than or equal to. So let me look for that symbol. Okay. So less than or equal to x, less than or equal to 240. Okay. So they begin at 0 and end 240 minutes later. Okay, so that's our domain. And let's see our range. Oh, they didn't ask what's our range. Okay, use the graph to determine how many minutes pass if the troop is below 3,200 feet. Draw an oval on the graph to represent this part of the function and write the corresponding inequality statement. Okay, so you want how many minutes have passed if the troop is below 3,200? Okay, so 3,200 feet would be right about here somewhere. And draw an oval the graph to represent this part of the function and write the corresponding inequality statement. Okay, so at this point, the minutes that have passed would be 80 minutes. So it'll be right about here. So it's going 40, 60, 30, no, 30, 60, 90. So it'll be right about 80 minutes right here. Okay. So we're gonna do a, let me see if I can do an oval. Okay. So we're gonna do an oval. That's not gonna work. Okay, I'm gonna have to draw it then. And don't worry about you drawing it. Okay. Okay. And let me just answer the question. Write the corresponding statement. Okay. So it appears to be 80 minutes. Or more to half past 3,200 feet. Okay, and our equation would be m is greater than 80. So after 80 minutes, everything after 80 minutes, you will be under 3,200 feet. So use the graph to determine how many minutes pass if the drop is below 3,200 feet. So all of that part is under 3,200 feet. So you can get that after 80 minutes. So 80, 90, 100, all of those make sense because those are all numbers that are going to be less than 3,200. So write and solve inequality to verify the solution set. You interpret from the graph. Okay, so we want our answer to be less than 3,200. So we're going to write down the equation. Negative 20m plus 4,800 is less than 3,200 feet. Okay, so we solved this. So I'm going to subtract 48 from both sides, 4,800 from both sides, and then divide it by negative 20. Okay, so let me go ahead and use the calculator for that. So we go 3,200 minus 4,800 divided by 20. Okay, so I get m. Well, the answer was m was less than 80. Okay, but okay, this would be under 80 minutes. You would be under 3,200, and it's not true. So because we divide by this negative number, we're gonna have to change the symbol to greater than. So after 80 minutes, okay, it should be after 80 minutes, then you're gonna be under 3,200 feet. So compare and contrast the solution set you wrote using the graph of the function. What do you notice? Well, we got the same answer. So that's the important things. It doesn't matter what way you use, the graphing or the solving algebraically. So the solution set should be the same, regardless of the strategy used. Okay, so even if you graph it or if you use algebraically, you solve it, it should be the same answer. Okay, so analyze the relationship between the inequality statement representing h of m and m. Complete the table by writing the corresponding inequality statements that represents the number of minutes for each height. Okay, So when would you be greater than 3,200? Well, you're going to be at greater than 3,200 when M is less than 80 minutes. Okay. When would you be greater than or equal to 3,200? Well, that's going to be when M is less than or equal to 80. When would how many minutes would have passed when you're exactly at 3,200 feet? Well, it's going to be exactly at 80 minutes. Okay. Okay. When will you be under 3,200 feet? Well, that's going to be after 80 minutes. And when would you be lower or equal to 3,200 feet? Well, that's going to be at 80 and greater than 80 minutes. Okay. So let's see, let's go ahead and write that on our answer. So let's see, we got M is less than 80. We got M is less than or equal to 80. We got M equals to 80. And we have M is greater than 80. And we have M is greater than or equal. So let me go get this other symbol. Oh, here it is, greater than or equal. No, that's the less than symbol. I want greater than. This is greater than. Copy, copy, and paste. There we go. Okay. So there's our answers. Okay, and they had them for us right there. M is less than 80. Okay. Compare each row to the table. What do you notice about the inequality signs? Well, I noticed the inequality signs are inverse. This is greater than, this is less than, greater than or equal, less than or equal. So the symbols are switching, okay? And it has to do with the slope being negative. That's why we have to, the symbols are being switched. If it was just going straight up, it would be, if you start at 0 and you go into 4,800, then the symbols will be looking the same way. So compare, so what do we notice? Well, we notice that inequality signs are reversed. Okay, explain your answer from part B. Use what you know about solving inequalities when you have to multiply or divide by a negative number. So when we multiply or divide by a negative number, we have to switch the symbol. Okay. So when we multiply or divide by a negative number, we switch. Say switch, or we have to say swip. Say reverse the symbol. We have to reverse the symbol. Okay, so the inequalities that you have solved in this lesson so far have all been two-step inequalities. Let's consider inequalities in different forms. So here we have two students, Allison and John. So Let's take a look at Allison. Got 5x plus 2 equals greater than or equal to 3x minus 10. Looks like she subtracted 3x from both sides. And then she subtract 2 from both sides. So you get x is greater than or equal to negative 6. John, on the other hand, instead of subtracting the 3x, he subtracted the 5x. Okay. And then you add 10, so kind of like doing the opposite of what Allison did. And he gets negative 6, it's less than x. Now the question is this, are those both answers the same? Well, they actually are the same, okay? It's like if you have a younger sibling, and let's say your younger sibling's name is Johnny, you can say Johnny is younger than me, or you can say I am older than Johnny. So both statements are correct, but you just say it differently. One of them, you're saying he's younger than you, and the other one, you're saying you are older than him. Okay, so same thing here. Here it says x is bigger than negative 6, and here it says negative 6 is smaller than x. So, okay. So describe the process each student used to solve the inequality. So again, Allison, subtract 3x from both sides. By the way, that's why I would do it. I like to keep my x's on the left side. So this is how I would do it. Okay. So let's see, Allison. So Allison moved the variables to the left side. And the numbers without variables to the right side. Okay. And that's how you solve it. All the variables to the numbers to the left side, all the numbers without variables to the right side. And let's see. And John, on the other hand, he moves the variables, numbers with the variables to the right side and numbers without variables to the left side. So John moved the variables to the right side and the numbers without variables to the left side. Let me get rid of this here. How does the process of solving inequality with variables on both sides compare to the process of solving equations with variables on both sides? The process is the same. And you can write down what the process is, move the letters to the one side, move the numbers without the letters to the other side. Okay, now we got Quran. Okay, so Quran is, let's see. Okay, so it looks like Quran distribute negative 4 times x, negative 4x, negative 4 times negative 6 is positive 24. And then subtract 24 from both sides. Okay, and just solve for x. He divided by negative 4 and he did flip the symbol. It went from less than to greater than. Oh, we got to describe the process. So that was described. Okay, so Quran distribute first. So distribute. Quran used the distributive property to remove the parentheses. Okay. Then he solved for was it x? Yeah, solved for x. Okay, Johnny, let's see, how did he do it? Okay, so instead of distribute, he divided both sides by negative 4. Now, I do this sometimes, but before I do it, I like to look at the number that is on the other side and see if that's divisible by the number that I'm dividing by. Notice how the number becomes negative 5.5. So I wouldn't suggest dividing by -4 just because I don't want to deal with the fraction. I prefer to get the fraction at the last step instead of the step before the last second to last step, where we have to deal with -5.5 plus 6. So yeah, so that just a hint. If you're going to divide, make sure the number on the other side is divisible by the number you're dividing by. So who's this one? Let me see. Who was it? Johnny. So Johnny divided both sides by -4 to remove the parentheses. Okay. How does the process of solving inequality using the distributive property compare to the process of solving equation using the distributive property? Okay. So it's the same. So using this is the process is the same. Okay, it's about solutions more or less. So solve each inequality and graph the solution set to the number line. So in this case, I'm going to graph it. You're just going to come up with the answer. Okay, so I'm going to, let's see, I'm going to multiply by 3 because it's being divided on this side. And I'm going to divide by -2 because it's being multiplied by -2. I'm dividing by a negative, so I'm going to flip the symbol. So I have x is less than or equal to, so 7 times 3 is 21. 21 divided by -2 is -10.5. So I'm going to say this is -10. This is -11. So -10.5 is going to be right there in between -10 and -11. And it's all the numbers that are less than that. So all the numbers less than that would be to this side. So your answer would be x is less than, so now I gotta go back. Less than -10.5. Okay, now let's go ahead and do this one. Okay, so I'm going to minus the 23 from this side, minus the 23 from this side. So 32 minus 23 is 9. I'm going to divide by a -1 to make our x a positive. Since I'm dividing by a negative, I'm going to flip the symbol. And I'm going to rewrite it. And instead of saying -9 is less than x, I'm going to say x is greater than -9. I'm going to have -9 right here. This time it's going to be an open circle. There's no line on the bottom. And we're pointing in this direction. So x is greater than -9. Okay, and let's go ahead and do this one. So here I can distribute or I can divide both sides by 2. Since I know 10 is divisible by 2, I'm just going to go ahead and divide both sides by 2. So I get x plus 6 is less than 5 minus 6 minus 6. So x is less than -1. So I'm going to put -1 right here. open circle, and it's going in this direction. So x is less than -1. Okay, almost done. Okay, so this one. Okay, so let's get the x's to one side and get the x's, the numbers without x's to the other side. So I'm getting -3x right here, -3x right here, and then I'm getting -15 from here and -15 from here. So I got -7x is less than or equal to -6 minus 15 is -21. Divide both sides by -7. Since I'm dividing by a negative, I'm going to flip the symbol and I'm going to get x is greater than 3. So I'll put 3 right here, make it a closed circle because we do have an equal to part, and it's going in this direction. Okay, x is greater than 3. Write down the answer because, yeah. And let's see. If A is greater than B, identify the constraints to make each statement true. So if A is less than B, there's no constraints, so it would be all. So this the statement will be is true for all values. Okay. Because it's already since C is equal to C, as long as A is smaller than B, that is always going to be true. AC is greater than BC. Well, this is a little bit different because now we're dealing with multiplication. So the statement is going to be only true when C is less than 0. Okay. And that's it. Perfect. Perfect timing.